Good afternoon, guys. Welcome to Videos Online Academic Tutorial. Thanks for watching our videos online. Please, if you haven't subscribed, please do it to press subscribe button and notification bell. And also all of our educative videos online. Please do it to share this video with your friends, families, relatives, and colleagues at home. Thank you and God bless you. Today we are going to be considering what the topic called qualitative analysis. Qualitative analysis is a technique used in what? In the laboratory in order to test for what? For gas, cations, and anion in a given sample. And this is one of the questions that why asked in the chemistry practical exam, especially question number 2. And here is a question before us to practice for the for 2022 while chemistry practical this year. So I want to employ you to watch this video to the end. It's going to be very interesting. Now, C is a mixture of two inorganic salts. Carry out the following exercise on C. Record your observations and identify any gases above. State the conclusions you draw from the results of each test. Now, we are asked to carry out exercise on the mixture of two inorganic salts, which is labeled C. Now, this is the salt here. We have the salt here. You can see the salt is a mixture of is a mixture of two inorganic salts. So, the first instruction says, put C in a beaker and add 10 centiliter cube of distilled water. Stir well and then filter. So this is the beaker. We have beaker here. So we have to add this to the beaker. Then we add 10 centiliter cube of distilled water. 10 centiliter cube of distilled water. So, I have 10 centiliter cube of distilled water here. So, that is that. Then we have to stir very well. We have to stir now. So, stir very well now. I'm stirring this. So, stir very well. So we have add our 10 centiliter cube of water to the mixture. So I'm stirring now. So this is the stirring. The stirring has been done now. Keep stir well and filter. Then we have to filter now. We have stirred. Let's filter. Now using your filter paper now. So you fold your filter paper like this. Then you have fold it into 2 equal halves now. Then the half also you fold it. So you have the cone here. Then open it from one side here to form a cone. So you place the cone on the funnel. Then you place it on one of the test tubes. Then you pour your your mixture. So that's that about that. So while we wait for the filtration to be complete. So I would like to continue with the table. So let's prepare the table. Now let me get my card so as to draw the table. Now the filtration is ongoing now. Let's draw our table out now. The first thing is you have to draw your table. You must create 4 columns. So we have the column for the serial number, because your serial number must be in order in order to follow the work systematically. So we have the serial number, we have the test column, the observation column, then the inference. We have the test column, the observation column, then the inference. So Now, the first thing which we will have to do is to what? Add water to C. So C plus distilled water. So you can abbreviate the water with what? H2O. So represent it with H2O. So then filter, stir, then filter, then filter. So what do we have? So the filtration is still, the filtration is yet to be completed. So let's use the opportunity to fill the rest. Now, being Roman figure what? 1 to about 2 centimeter cube of the filtrate. Now, the B Roman figure 1 now is what? To about 2 centimeter cube of the filtrate. So this filtrate, you take 2 centimeter cube of the filtrate, add aqueous sodium hydroxide in drops and then in excess. So we have to add what? To first 2 centimeter cube of filtrate. The first 2 centimeter cube of what? Of filtrate. First 2 centimeter cube of what? Of filtrate. Plus sodium hydroxide in, we have in drops, then in SS. In SS. So what do we have? So that is the first question under B, Roman figure 1B. So now we have what? Roman figure what? 2 under B. We are now saying, we are now told to what? The mixture that you obtain here, you have to warm it. So warm the mixture. So the mixture in 2BI, because the question is about 2, so 2BI now plus what? Warm or heat. So when say warm, they are trying to say what? Should heat it. So now what's your observation and what's your what? Inference. Now remember we got what? 3 of the B. Remember we got 3 of the B. So another 2 centimeter cube portion of filtrate. So the second 2 centimeter cube. Second 2 centimeter cube of what? Filtrate. Second 2 centimeter cube of what? Filtrate. The second 2 centimeter cube of what? Filtrate. Add what? What are we have to add? Barium chloride solution. Add what? Drops of what? Barium chloride solution. Plus what? Excess what? ACl. Excess ACl. That is aqueous. Then you write the word observation as well. Then the next one is what? C Roman figure what? 1. C Roman figure 1. C Roman figure 1. And when you are talking about C Roman figure 1, what are we have to do? You have to what? Put all the residue into clean test tube and add what? HNO3. So C plus what? So remember, put all the residue. That is the residue of the C. The residue obtained from the mixture of C now. We have to what? Residue plus HNO3. So what do we have? So another thing that we also have here again is to a portion of the solution from 2CI. So whatever you obtain here, you divide it into a portion. You take the portion, so C Roman figure what? 2 here. So we have what? Portion of what? The portion of 2C Roman figure 1. 2C Roman figure 1 plus what? Aqueous ammonia in drops. Then in what? In excess. So this is what we have to carry out in the what? Experiment. So we have what? I like the questions that we have to answer in the what? In the table. Now let's look at our what? The filtration is still going on. So while we are still waiting for it, let me get a marker. So the filtration is still going on. We have what? We have the what you can see. We have what? Deep blue what? Filtrate here. We have the deep blue what? Filtrate. We have the deep blue what? Filtrate. Then you can see that the residue that we are going to have there is a little bit what? Lighter than what? Than the blue filtrate that we have here. So I want to have what? Blue filtrate, deep blue filtrate, then light what? Light blue residue. So we can see that when we add what? Water to this, we have what? Deep blue what? Filtrate. Deep blue filtrate, then light blue residue. What does it mean? Now the residue is what we have on the filter paper, while the filtrate is what we have in the what? Test tube. So it means that what? Since you have the filtrate, you have the residue, it means that the salts react together to form soluble and insoluble salt. So the one that is soluble is what we call filtrate, the one that is insoluble is what we call what? Residue. So we now say C is a what? C is a mixture of soluble and insoluble salts. So one of the what? Salts is what? Soluble, while the other one is insoluble. So that's the two salts. So we can, from the first step of the reaction, we can see that what? One is soluble and one is insoluble. So we have drawn our what? Inference from that. So to this first, now to the first 2 centimeter cube of filtrate, add what? Sodium what? Hydroxide. Because sodium hydroxide, it drops then in what? In excess. So we have not yet what? Complete what? Filtration, but here we have enough for 2 centimeter cube for us to measure 2 centimeter cube. So I will have to transfer this to the other test tube. So now let me measure what? 2 centimeter cube of the filtrate. 2 centimeter cube of the filtrate. So this 2 centimeter cube of the filtrate. So let me put it inside another test tube. So to this 2 centimeter cube of the what? Of the filtrate, we have to add what? Sodium hydroxide in drop. Add sodium hydroxide in drop first and observe the color change. Let's add it because okay, you can see the what? When you have this in drop, this turns to what? To what? It turns to what? Light blue what? Precipitate. In drop, we have what? Light blue what? Precipitates. Then we have what? The light blue what? Light blue precipitate formed. Light blue precipitate what? Formed. Then when you have more of it, what do you have? When you have more of it, light blue precipitate, when you have more of it, the light blue precipitate what? Persists. The light blue precipitate what? Persists, that it remains. So the light blue what? The light blue precipitate remains, that is, remains insoluble, remains. So what does it mean? This container what? It means that what? This solution here, this filtrate consists of what? C2 plus. So C2 plus is what? That is copper. Cu2 plus, which is copper ion, is what? Present. So copper ion is present in this what? In this mixture. So that's that about what? So copper ion, it means copper ion is what? Because copper ion does not dissolve in excess what? Sodium hydroxide does not dissolve, but the what? The blue precipitate remains when what? When you put any copper what? Containing compound inside what? Aqueous what? Sodium hydroxide, the blue what? precipitate remains. There's no changes, it does not dissolve, and does not become deep what solution. So that's that about that. We are now asked to what? The set mixture from this place. Now, what we get here, we should what? Warm it. That is, we have to apply what? Heat to it. So now, let me on the what? The gas cylinder. So we have the corner now. So let's push up the test tube holder to hold the test tube by heating. So I want to put on it so that you can read what, allow the heat to touch the word, so that you can see the color changes very well. So I need to clean this very well. So now just the heat enough is enough to. Now you will see that the blue precipitate here will change. The blue precipitate will change. It's changing already. You can see the blue precipitate here. The precipitate here. With time into what? It will change to what? To black. From blue to black. On warming. And you can observe a sound. A sound like it's because I'm not putting it on it, so that's why it's not fast. So as to see change that is taking, you can see that the color is changing already. The blue thing is changing gradually. When you leave it with time, I will have to put it down. With time, it will change to black. So we have to warm it, not to eat it. So we have to warm it. So I just want you to see black before I drop it. So now you can see the color is changing a little bit gradually. So I will switch off the thing now. Then I will leave it. You see the old blue thing is going to change to black. It's going to change to black. So you can see that the color has been changing. So let's just leave it. Now everything will change by itself now. So let's leave this one. Everything will change to black. So it's not as a result of the what. You can see the color is changing. Now when you leave it, it will change completely. So let me off the what. Now we are done with that. So what we are going to write here is that the light blue precipitate turns what? Turns black. So what does that mean? It means what? CU what? It means what? CuO from what? That is copper 2 oxide from copper hydroxide formed. Must obtain. So we have what? CuO from what? Copper oxide was obtained. So that is why the blue precipitate turns black. So whenever you have what? Copper changing, whenever you have a copper containing what? Compound changing from blue to black, it means that what? There's we only have the copper 2 oxide left in the what? In the solution. So you can see now everything has become black, completely what? Black. That's what I'm saying. So that's that about what? The question number what? Number 2. Now number 3. The second 2 centimeter cube of what? Filtrate plus barium chloride. The second 2 centimeter cube of barium what? Now the second 2 centimeter cube of what? Filtrate. So now let's measure another 2 centimeter cube of filtrate. 2 centimeter cube of what? Filtrate. So this is another 2 centimeter cube of what? Filtrate. Then we have to add what? To 2 centimeter cube of filtrate, add what? Barium chloride. Add barium. These are barium chloride. Add barium chloride. So when I add barium chloride now, what do we have? Add barium chloride in drops. We have what? We have a little bit what? You see, in drops, you can see it now. Then, now let's add ACL. Let's add ACL to see the changes. Now, the ACL here, we have ACL. So, ACL now, we have a what? A white precipitate. Whenever you add barium chloride to a what? To a filtrate, and then you add ACL and you have white precipitate, it means there are what? So there are cations, there are anions in that what? Solutions. So the white precipitate represents what? It indicates that there are cations in the what? In the filtrate. So now white PPT formed indicate that there is a presence of what? There is presence of SO3 2 minus, SO4 2 minus, or CO2 3 2 minus is what? Is present. Now, because we now what? The red precipitate now persists in essence. Now let's see whether white precipitate insoluble in essence. Let's see that whether it's insoluble in essence. In excess what? In excess ACA. Then what are we going to have? When the white precipitate insoluble in excess of ACA, we are going to have SO4 2 minus confirmed. SO4 2 minus confirmed. Now let me add more of it so that you can see what I'm trying to say. It's already in excess, but let us add more. You can see the white precipitate still what? Persists. So it's insoluble. You can see the precipitate settling down here. So that's that. So SO4 2 minus is what? Is confirmed by doing. So now we are done with that. The next thing now is what? See Roman figure 1. Residue plus HNO3. Now we have our residue here, which is our light blue water residue. Now we have to put all of the residue into the what? Clean test tube. So we have to put all of our residue into clean test tube. So now let me try and rinse this because I don't want to use this broken test tube. Now let us put this one together and quickly rinse it because we have to use clean test tube. So this is a clean test tube now. Clean test tube. So make sure your test tube is what? Is clean as instructed. So now add the what? All of the residue here. So add all of the residue. I've added it now. So make sure everything enters. We don't have anything at the what. So now to that residue now add HNO3. To that residue add what? HNO3. So what happens when we add HNO3 to it? There's effervescence. You can see there's effervescence taking place. So make sure you rinse the what? The side. So there's effervescence taking place, trying to can use glass rod to clean your what? The side of us so that you don't have any. So now let me try and rinse it with what? The side with. So that's that about. So you can see evaporation has taken place. Now you can see the gas coming out, evaporation. So there's an evaporation of gas. So we have what? Evaporations of a gas. Now if you test that gas with what? Blue litmus paper, if you turn blue litmus paper to red, so evaporation of a glass will turn blue litmus paper red and turns lime water milky. So that's the characteristics of what? Of CO2. Evaporation of a gas which turns what? Blue litmus paper, blue litmus red, and what? And turns lime water milky, and turns lime water milky. So that's that. You can see complete evaporation has taken what? Has taken place. So what does that mean now? We have what? CO2 from what? CO3 to what? Minus. Confirmed. So that's that about that one. Now the next thing now is to what? They said what? To the portion of 2Ci, to the portion of this now, to the portion of this, add ammonium aqueous in drops, then in excess. Add ammonium aqueous in drops, then in excess to the portion of this. So try to create another test to empty this one since we are not using this one again. Or we can as well what? Turn this one to this because I want us to have the results. Turn this to this so as to have So let me quickly mix this with my distilled water. Now, to a portion of what? Of the mixture obtained here, portion of 2C obtained. So to a portion of C obtained here, a portion. So this is a portion now. We have to add what? Now we have divided into two portions now. So this is one portion of it. Now we have to add what? Aqueous sodium hydroxide. Aqueous sodium hydroxide. Aqueous sodium hydroxide. This is aqueous sodium hydroxide here in drops. Aqueous sodium hydroxide in drops. So we have in drops. In drops. You can blue precipitate is on. Now I have blue precipitate. If you add it, we are going to have blue precipitate form. Now there's a blue precipitate form in drops. So when they say in drops, so blue precipitate what? Blue precipitate forms in what? In drops. In drops. Blue precipitate forms in what? In drops. Then in excess, now let's see, in excess, if you want to add in excess, let's see. You can see in essence now, the blue has dissolved to form what? Deep what? Blue, if I continue to add it. So you can see the blue formation, and that's how it will be dissolving. The blue will be continuing to what? To dissolve. Let me add a little. So that's what it is. So that's in essence. So we can see a deep blue. So the blue precipitate dissolved to form a deep blue what? The blue precipitate dissolved. The blue precipitate dissolved to give a deep what? Blue solution. A deep blue solution in excess what? aqueous ammonium. In excess aqueous what? Ammonia. So what do we get here? Cu2 plus is present. So, and then is the confirmatory test, because when copper dissolve in excess what? Ammonia, aqueous ammonia. So we have Cu2 plus what? Confirmed. Cu2 plus what? Confirmed. So we have come to the end of the what? Analysis here. Let me separate it very well so that you can see it. So here is what? The analysis. The first one, the second one, the third one. The first one gives us what? Filtrate and residue. We are asked to what? And we are asked to mix what? The mixture of what? The mixture of C when dissolved in water and then filter give us residue and what? You can see it gives us residue, a deep blue what? A deep blue what? Filtrate and a what? A light blue what? A light blue residue. So that's why C is a mixture of soluble and insoluble salt. So that's the first question asked. Now we are now asked to what? To this what? Filtrate. We are asked to add what? We are asked to add sodium hydroxide, which gives us what? Kind of light blue, which shows that Cu2 plus is what? Present. Then we are asked to heat the mixture, which gives us what? You can see copper 2 oxide, which is a black what? Which is black. So that's why we have copper 2 oxide from copper hydroxide. So that's that. The next one was what? We used it to confirm what? SO42 minus, we are adding barium chloride, and we can see that the what? The white precipitate does not, is it soluble in what? In SSC here, you can still see it here. And the last thing is what? When you add what? Aqueous ammonia to it, we have blue PPT for a drop. Then in essence, it becomes what? It dissolves to give deep blue solution. So we have come to the end of today's class. If this class has really helped you, please do well to subscribe and press the like button. Let's see all of our educative videos next time. Thank you. Keep on watching what videos on our academic tutorial and keep on sharing.